The quotient rule is another rule for taking derivatives that you'll find extremely useful. The theorem says if I need to find the derivative of the ratio of two functions, f of x over g of x, it's simply equal to f prime of x times g of x minus, keep in mind that's a minus, I'll come back to that in just a second, f of x times g prime of x over g of x squared. Now, the way I remember this is simply this piece right here. This is just like the product rule, except the product rule has a plus here. So the product rule adds these two, and the quotient rule subtracts them. And then, of course, just divide it by whatever this function is in the denominator squared. So that's it. It's really simply a formula you need to remember so that you can do it. I'm not going to go through the proof of it, although you could with the limit definition of a derivative, just like we did with the proof for the product rule. It's the exact same sort of a thing. Let's just jump into a couple of examples. I'm going to call this f and call this one g. I know that I'm going to need derivatives for both. So off the side here, I'm going to say, okay, f prime of x will be 6x minus 1. And I know g prime of x will simply be 1. So now I can put it together using this format right there, that formula. So the derivative of this is going to be equal to 6x minus 1 times g of x, which is x plus 2, minus f of x, which is 3x squared minus x, times g prime, which is just 1. And obviously that 1 doesn't do anything, but I think it's a good idea when you're first doing this to put it in, just so you kind of remind yourself when you're looking at your work later where that came from, so you know you'll have all the pieces. And then in the bottom here, I'll have x plus 2 quantity squared. Now, I'm not going to do it at this point, but you should probably expand these and see if you can simplify. X plus 2, do not cancel these out. You can't cancel these because of this negative. That's a very common mistake. If I had an x plus 2 over here someplace, then I could cancel one of them out, as in cancel here if it was there, and one of these. But I don't have an x plus 2 there, so don't be trying to cancel that out. And let's take a look at another example. The exact same idea. I'm going to call this f, and I'm going to call this g. I know I will need f prime of t this time, which is 12t squared plus 3. And I know I'll need g prime of t, which is 10t to the fourth. So now I'll just put it together. And remember, the format is going to be f prime g minus f g prime over g squared. So I'm going to say this derivative is equal to 12t squared plus 3 times 2t to the fifth minus 4t cubed plus 3t plus 1 times 10t to the fourth divided by 2t to the fifth squared. And again, you probably want to distribute here and see if you can't simplify. You may or may not be able to simplify, but you won't know until you give it a shot. But really, that's all there is to the quotient rule.